Okay, in this video we're going to be talking about perpendicular and parallel lines and how to find the equations of those lines. So when you draw these lines on a graph or a piece of paper, you know that you can make them perpendicular simply by drawing them at right angles from each other. So in this case, the orange line here is perpendicular to the green and the blue lines because it is at right angles with them. And if you want to make two lines parallel to each other, you just want to make sure that you draw them in such a manner that they never actually cross or intersect at any point. So mathematically, the way that we would describe those relationships between the lines is saying that lines are parallel if they have the exact same gradient. So for example, if we grab these two lines here, the green and the blue, we can say that the gradient of one of them should be equal to the other one in order for them to be parallel. And the reason for that is that if they have the same rate of descent or ascent, so remember that basically this is as the same as putting a disk on top of it and letting it roll. If they both roll at the same rate, then we know that those two gradients are going to be the same because it's the same incline. However, if we want to make lines perpendicular to each other, then the following relationship between the gradients must be satisfied. So one of the gradients must be equal to the negative reciprocal of the other one. So if this relationship is satisfied, then we say that the lines are perpendicular. And if neither of these two relationships are satisfied, then the lines are neither parallel nor perpendicular. So that's the main concept that we need to understand in terms of relationships between lines. Now in this question we're going to be doing that same thing. So we're given some equation of a line and we're told to find the equation of another line which is parallel to this one passing through this point. So we're given the key words here, parallel and passing through that point. So what we know from parallel lines is that the gradients should be equal. So that means that let's call this one line 1. So that means that for line 2, we should have m2 equals to this same gradient. So that should be 3 as well. And basically, we can write the equation of this other line in the same manner. But now we gotta find the y-intercept. So unless they are the exact same line, they're gonna have different intercepts. So what we're going to do here is we're just gonna plug those values in to find b. So we're gonna have 0 here, and then 4 on the left hand side, and then that means that b is going to be equal to 4. Therefore, the equation of the line that is parallel to this one and passes through that point is going to be 3x plus 4. So you can see that if you were to draw these two lines on a set of axes like this one would cross the y-axis at the point -1. So, and because it's a positive gradient, it would go like that. And this one, since it would cross the y-axis at the point 4, so it would be somewhere there. But since they have the same gradient, they're never actually going to cross each other. They're never going to intersect. So we say that they're actually parallel to each other. Now for the next question, we are given an equation of a line, but we're told to find the equation of a line perpendicular to it, and it is passing through this point. So, from our definition earlier on, we know that lines are perpendicular if the following relationship between the two gradients is satisfied. So once again, let's call this line 1, and then line 2 is going to be the following. So we're going to find m2. If we rearrange this equation, we can just write m2 here and m1 over there. And what's the gradient of this? Well, that's 2, right? So we're just going to write -half. And that's going to be the gradient of that line perpendicular to it. So we can write the equation y equals to -half x plus b. And now in order to find the y-intercept, we just plug in those values. So we're going to have 0 on the right hand side plus b, and then -1 over here. So b is going to be -1. Which leads us to the equation of the line, which is -half x minus 1. Okay, so you will always see this kind of relationship if the lines are perpendicular to each other. One of them is going to be the same as the other, but it's going to be 1 over that gradient, and it's going to be negative. And if you think about it, that's the only way it can be, because if you have some line going this way, any line that is perpendicular to that one will have a negative gradient, because if you put a disk here, this one is going to roll to the left, whereas this one is going to roll to the right. And you can play around with that concept a little bit, and you can see that there's no way you can make those two lines perpendicular unless those two disks are going to roll in opposite directions. So that's one way you could think about it. And now for the last question here, we're going to find out, okay, so are the lines, this one and that one, parallel to each other? Now you can see that we need to rearrange them, because obviously we cannot really work with this as it is. We need to find the gradient and y-intercept. So we're going to rearrange each of them. So this first one is going to be y equals to 3x plus 6. So we can already tell that the gradient is going to be 3. Now for the second one, we can so let's call this one line 1, and then line 2 is going to be the following. We have 3y equals to minus x minus 15. And then if we divide both sides by 3, we're going to get y equals to minus 1/3 x minus 15 over 3, which is 5. So are the gradients the same? Well, clearly they're not the same. So we say that they're not parallel. But if you notice very carefully, it turns out that this one is the negative reciprocal of that one. So what that's telling us is that these two lines, if we were to draw it like this, we have 3 equals to minus 1 over 3. So basically what that's telling us is that, well, actually it's not really like that, because that's not a proper equality, but basically if we write it like this, the second gradient is going to be 1 over 3. That's more like it. So we have 3 minus 1 divided by 1/3. So we can do that multiplication that we know of, 1b c d. So we multiply those two and those two, and then this is going to come out as the following. So let me just write, I forgot the negative sign here. So that's going to be minus 1/3. These two are going to cancel out, and we're going to be left with 3 on this side. So by plugging those two gradients into this equation, we can actually find that since they give us the same number, those two lines are going to be perpendicular. And this is an important concept, because later on when you go into year 10 and 11, you're going to be dealing a lot with something called coordinate geometry. And everything in geometry can be summarized in terms of either straight lines, triangles, or circles. So basically you're going to be extending these concepts a little bit further, and then you're going to be doing more sophisticated stuff with them.